In this video, we'll be discussing Rain-Man problem. In Rain-Man problem, actually there are three vectors. First is velocity of rain, the second is velocity of man, and the third vector is velocity of rain with respect to man. You can say that velocity of rain is nothing but the resultant of these two vectors, velocity of rain with respect to man plus velocity of man. So a triangle must be formed like, if this is velocity of rain with respect to man and this is velocity of man, then this will be the velocity of rain. Okay, or if this is velocity of rain, we can say velocity of man, velocity of rain with respect to man. Okay, so a triangle must be formed like this. Resultant of these two will be VR. The resultant of these two will be VR. There are a few important things about them. Velocity of rain is constant. It doesn't change if you change Vm, and VR by m will be subsequently changed because it depends on velocity of man. If you run fast, slow, change your direction, VR by m will change, but VR will not change. Okay, this is the key point for the analysis. Velocity of rain will not change. So there are two important factors. Let's discuss two important cases. In first case, rain is falling vertical. Rain is falling vertical. So when the rain falls vertical, velocity of rain is this, and we can say that the man is moving with some velocity Vm1. So velocity of rain with respect to that man 1 will be this. Now if it changes its velocity, let's say it increases its velocity again, don't change this vector, this is Vm2. The new relative velocity will be this, Vr by m2, but this vector will not change. Similarly, if it decreases its velocity, let's say this, Vm3, the new relative velocity will be this, velocity of rain with respect to man in case 3, but again this vector will not change. So that is the overall concept. This vector will not change. If you change, this junction will get shift towards this side or that side, only this vector will not change. The second important case is rain appears to fall vertical. Rain appears to fall vertical. In that, we can say that this will be the velocity of rain with respect to man. If man run in this with some velocity, then this will be the velocity of rain. If you change this, again this dotted vector cannot be changed. Subsequently Vr by m will change and it will not remain any more perpendicular. For example, if this is increased Vm1, the new relative velocity will be this, Vr by m1, and if it is decreased Vm2, the new relative velocity will be Vr by m in 2. Okay, but the vector Vr will not change. Again, the only junction you can shift is the junction joining Vr by m and Vm. So these are the major concepts involving Rain-Man problem. In this question, the rain is falling vertical. If a man runs with 3 meters per second, raindrops hit him at an angle of 37 with the vertical. We have to find velocity of rain and velocity of rain with respect to man when he is running with 3 meters per second. And now if he starts running with 4 meter per second, what will be the speed of rain drops and at what angle they will hit him. So again, velocity of rain is vertical. We can say let the man is running with 3 meter per second, Vm. So the velocity of rain respect to man will be this, and this is given that raindrops hit him at an angle of 37. So using tan theta, you can say tan 37 is equal to VR by 3, and we get VR as 3 by VR. Made a mistake. VR as 4 and VR by M as 5. Okay. Similarly, if we have to find out what will happen if man now start running with 4 meter per second, let's say again this vector will be increased to 4 meter per second, and the new relative velocity will be this VR by M in case 1. This is Vm1. So this angle, as this is 4 and we have already calculated this to be 4, this angle will be 45 degrees. So we can say rain hit him at an angle of 45 and new VR by M1 will be 4 square plus 4 square root of that, just 4 root 2. In this question, rain is falling with 10 meter per second at an angle 53 degrees with vertical. We have to find the speed of the man with which he should run so that rain appears him to be vertical. Now, the velocity of rain is this 10 meter per second at an angle of 53 degrees with the vertical. Now, we have to find at what speed velocity of man should be there so that rain appears to be vertical. Again, this is the triangle, we know this angle, and using trigonometry I can say sine 53 is Vm by 10. So Vm will come out to be 8 meter per second and VR by M in this case will be 6, using again trigonometry. Now if the man further increases his speed, let's say Vm new, Vm1 is 15 meter per second, or let's say 16 meter per second. He doubles his speed. At what angle the raindrops will hit him? Okay, so we can say the vector will remain same, this vector, and this will increase. The new vector will be 16. This was actually 8, and the remaining, this will be the new VR by M with respect to 1. Again, this vector will not change. We have to find this angle as well as the remaining part is also 8, and we have already calculated this to be 6. The theta will again come out to be 53 degrees, and VR by M in case 1 will be 8 square plus 6 square root of that, that is 10 meter per second. Okay, thank you.